Hey guys, today we're going to complete section 5-4, and that's going to be all about multiplying and dividing fractions. So let's start with this first example, 6/7 times -1/3. For now, I'm going to ignore the negative sign, and I'm going to decide what 6/7 times 1/3 is. Now, multiplication's very simple. All we have to do is multiply straight across. So what would that look like? Well, 6 times 1 is 6, and 7 times 3 is 21. I then have to go back and look at my positives and negatives. Positive times a negative. Don't forget your integer triangles. If I have a positive times a negative, the answer is a negative. So I see that it's negative 6/21. I, of course, need to simplify. I'm going to write this twice so that I can show you the two ways that we like to simplify. The first way for simplifying is using the giant 1. If I look at 6 and 21, I ask myself, what can both of those numbers be divided by? Well, I know they can both be divided by 3. Well, 6 divided by 3 is 2, and 21 divided by 3 is 7. Bring the negative sign over, and my answer would be -2/7. The other way I taught you to do this was to use your factor trees. I know that the factor tree of 6 for prime factorization would be 2 times 3. How about 21? Well, that would be 3 times 7. So I'll write that below. Then we look for things to cancel out. I can see that my 3's would cancel, slash those guys out, and I'm left with 2/7. And then, of course, we add this negative sign, so -2/7. At this point, I'd like for you to pause the movie, copy down this first problem, and then copy down one of the steps for multiplying these fractions. Another way to multiply fractions is with variables. This, again, is very easy. You're going to just multiply across the top. 5x times 2x. If I have 5x's and I double it, I get 10x's. And 7 times 3 is 21. So the correct answer would be 10x over 21. Pause the movie now and copy this example into your notes. A trick I like to teach my students is to actually simplify before you multiply. Well, what does that look like? I could easily multiply this 4 times 3 and get 12, and then 5 times 8 and get 40, and then figure out what to divide it by to reduce. Well, if I look for a number on the top and a number on the bottom, and if I see that I can divide those numbers by a number, I'm going to do so. Let's see. 4 and 8 can both be divided by, well, 2, but they can also be divided by 4. 4 divided by 4 is 1, and 8 divided by 4 is 2. If I multiply those now, 1 times 3 is 3. And 5 times 2 is 10. Well, what if I did it the other way? Well, I would have seen that 12 and 40 can also be divided by 4. 12 divided by 4 would give me the 3, and 40 divided by 4 would give me the 10. So this shows it really doesn't matter which way you do it, it's all up to you. Copy this example in your notes so you can see how to simplify your fractions before you multiply. The next thing we need to know is that it's always important to change to improper fractions before we multiply. Hopefully you remember this from elementary school. The way we change to improper fractions is we multiply the denominator by the whole number, so we're going to times that, and then we're going to add it to the numerator. At this point, I'm just going to ignore the negative sign, put it down there. So then I look at what I just said. 3 times 1 is 3, plus 2 is 5. So this fraction would be 5/3. Now it's very simple. Negative 5/3, don't forget that negative sign, times 1/5. There's a couple ways I can do this. 5 times 1 is 5, and 3 times 5 is 15. 15 divided by 5 is 1. And 5 divided by 5 is 1, and 15 divided by 5 is 3. I can see that the reduced answer would be 1/3, and a negative times a positive is a negative, so negative 1/3. What if I were to simplify before I multiplied? What would that look like? Well, I know 5 and 5 can both be divided by 5. 5 divided by 5 is 1, and 5 divided by 5 is 1. So now, if I multiply through, I see that 1 times 1 is 1, 3 times 1 is 3, a negative times a positive is a negative. So either way I do it, I get the same answer. Pause the movie now, copy the problem and one of these solutions into your notes. So the two things we've covered are just multiplying straight across for multiplying. For sure, we need to change all of our mixed numbers to improper fractions. And then we always have the possibility of canceling things out before we multiply through. That way we don't have to reduce at the end. Now I'd like you to pause the movie and copy these notes down. For division, we use the reciprocal, and I want you to try to remember this phrase, copy dot flip. Pause the movie and write all of this down in your notes. Okay, so let's see what this means. Well, very simple. Copy means the first number we copy. Easy. 5/8. The second number is dot, which means I'm going to change my division sign to a multiplication sign. The next thing is we're going to flip. Now the mathematical term for this flip is the reciprocal, which means whatever's on the top we put on the bottom, and whatever's on the bottom we put on the top. So instead of 3/4, I'm going to flip it to make it 4/3. Don't forget the negative sign. Now I can go ahead and multiply through. But before I do so, I'm going to use my simplifying rules. Look at this. I've got the 4 and the 8. Both 4 and 8 can be divided by 4. 4 divided by 4 is 1, and 8 divided by 4 is 2. I can go ahead and multiply those through. 5 times 1 is 5. 2 times 3 is 6. Don't forget, a positive times a negative is a negative. My answer should be negative 5/6. Pause the movie now and copy this example into your notes. Now let's say we didn't cancel before we multiplied. Say that we had 5/8 times negative 4/3. What would we have gotten? Well, a negative, of course, because a positive times a negative is a negative. And 5 times 4 is 20. 8 times 3 is 24. Looking at those numbers, I can use my divisibility rules. I know that both of those end in a 0 or a 2, so they're divisible by 2. But I might also see that they are divisible by 4. So, negative 20 divided by 4 is 5, and 24 divided by 4 is 6. As you can see, either way we would have gotten the same answer. Now, I'd like for you to try these two on your own and submit your answers to the form.